to be able to better take advantage of the capabilities that Ansible brings to enterprise organizations. So let me start off the session by acknowledging that most organizations are already automating. Some use special scripts, some use special tools, and some are even using standalone playbooks already. But for enterprises to be able to realize all the benefits that automation has to offer, they need to incorporate being able to coordinate at scale as part of their overall automation strategy. A common challenge nowadays is that many organizations have too many unintegrated domain specific tools, which may provide benefits on a small scale but presents a big problem as you try to automate at scale. And that's why breaking down silos is critical for an effective automation strategy. Enterprises need to have a single platform that will enable various teams across the organization to collaborate and therefore be able to coordinate automation at scale, which will allow for consistent governance across the organization's IT landscape. Today, this capability of being able to coordinate at scale has various facets, and when you look at it on a practical day-to-day level, some of the questions that needs to be answered are: how can we create an effective strategy towards consistent and secure OS management? How can we come up with an end-to-end, fully automated approach to provisioning, patching, and day 2 management so that we would be able to efficiently support more dynamic and dispersed environments? For us, the answer is Ansible Automation Platform. Let me give you three reasons why we think automation using Ansible will be able to address the challenges organizations face in an effort to automate at scale. Why Red Hat Ansible Automation Platform? Number one, Ansible is powerful. Ansible can automate a variety of infrastructure objects such as physical servers, VMs, cloud instances, storage devices, network and security devices such as switches, routers, gateways, load balancers, firewalls, and can also integrate with third-party solutions such as ITSM and CI/CD tools to allow for orchestration of complex processes at an enterprise scale. Number two, Ansible is simple. Ansible makes use of popular ways of securely connecting to managed nodes remotely. This is via SSH, WinRM, and NetConf. This provides a simple way to start using automation across various domains within the organization. Ansible also doesn't require special coding skills for teams to automate, which reduces the time it takes for organizations to become productive in automating using Ansible. And lastly, Ansible is agentless. Ansible does not depend on agents to be able to automate various infrastructure objects. This means you don't have to worry about maintaining and updating agents, which lessens the risk of the managed nodes being vulnerable to malicious attacks because of unpatched agents. This also makes it easier to integrate Ansible into hybrid environments. Ansible can work with a huge number of certified platforms and various use cases, spanning different environments from on-premise physical and virtual environments to private and public clouds, hybrid and even multi-cloud. Ansible can integrate with third-party solutions that organizations most likely are already using in their IT landscape. But before we jump into the most common use cases for Ansible, let's start off with understanding basic Ansible concepts. As mentioned earlier, Ansible does not rely on agents to communicate with infrastructure objects. Instead, it uses popular protocols like SSH, WinRM, and NetConf to securely communicate with them. This reduces the time needed to get productive with Ansible, since you don't have to install agents on each of the nodes you wish to automate. Ansible is declarative in nature, which allows organizations to describe each managed node's desired state. This enables various capabilities such as enforcing specific policies related to security, stability, performance, and also while ensuring each node is configured consistently and is always at the ideal state. Because Ansible is declarative in nature, Ansible allows for idempotency, which means that after setting things in their desired state, running playbooks multiple times on the same nodes will not result in any future changes. This means you can be sure that your environment is always in a consistent state. Ansible is able to identify which infrastructure objects to work on through the use of an inventory. Ansible inventories can either be static, which means that you manually list down the devices you want Ansible to work on, or dynamic, which means that Ansible will pull information from a central location, such as virtualization managers, cloud providers, LDAP, and many others. Ansible inventories also enable organizations to group together similar devices depending on applications, locations, availability groups, and so on. Ansible inventories also allow organizations to include specific variables relating to the hosts in host groups, such as what ports to use, where to get templates to be used in configuring applications, where executables are located, and so on. So as you can see here, we're able to group together servers belonging to the web and database groups. We are also able to group together network and security devices such as switches and firewalls using group names enclosed in square brackets. In inventories, you want to identify servers via hostname and IP address so that Ansible would know which device is which. Playbooks are Ansible's configuration, deployment, and orchestration language. Playbooks are human readable, which means no special programming skills is needed. It is easy enough to understand that even a non-programmer and a new team member can easily identify which task a playbook tries to do. Each playbook is expressed in YAML format, which makes it ideal to be managed the same way you manage application code. This means playbooks are easy to manage and also provides a way for version control and deeper collaboration between various SMEs for various domains within the organizations. Ansible playbooks consists of tasks which are executed in order, making it easy to understand what specific outcome will be achieved by running a specific playbook. So as you can see here, we are able to know right away that this particular playbook aims to install and start a specific service, like HTTPD. This playbook also shows what specific tasks are needed to ensure that the service exists and it is started and ready for use. Another thing to note is that you can enable Ansible to execute tasks as a sudo user, which allows Ansible to do administrative tasks securely. If you look at the tasks below, you can see there that we want to execute this set of tasks against our web server group. You can also see that we're trying to install the HTTPD package, identifying that we want the latest version of the package by the state keyword. And to ensure that HTTPD service is started, we can specify this by the state started keyword. As we also go along and make more complex playbooks, we are able to sift through the tasks that only make sense to a number of devices via the tags keyword. As you can see, playbooks can describe policies that you want to enforce to a group of devices, or it can also contain a series of steps in an IT process. To enable advanced automation tasks, variables, conditions, and loops can also be included in playbooks. Next up, Ansible roles makes whatever you automate using Ansible easier to reuse by other teams, as Ansible roles makes it possible to compile all needed artifacts such as templates, variables, and even modules in an organized file structure that can be easily copied and modified to suit whatever use case is needed. Because Ansible roles are organized this way, it also makes it easier to reference tasks, templates, files, scripts, and playbooks in order to achieve the desired state for your devices. Ansible roles can then be further organized into collections to make it easier to consume multiple roles as a group. Next, we also have something called Automation Hub, which makes it easier for organizations to start automating because it is the official location to find and download supported collections that organizations can then modify to suit their particular use case without having to start from scratch. And lastly, Ansible Tower is what really enables better collaboration between various teams within your organization. Ansible Tower also enables organizations to integrate with various third-party tools such as ITSM and CI/CD tools, external logging, and security solutions via REST API, and enables organizations to effectively and efficiently automate at scale by having the ability to schedule execution of jobs, store secrets such as login credentials, control which users are able to do certain tasks via RBAC, and connect to various providers to have dynamic inventories, and create multi-step workflows. As mentioned earlier, Ansible is very powerful that it can automate many things in your IT landscape. But for this session, we'll be focusing on server provisioning and management. In enterprises today, one of the most important tasks is being able to provision server resources for customers, for consumers. With Ansible, organizations can implement an on-demand, self-service OS provisioning workflow that can be initiated by consumers themselves. On the left hand of the slide, you can see that Ansible enables a way for various consumers from various teams across the organization to consume automation. Consumers can then call an API or log a ticket with a service management tool for a provisioning or patching request. This is just one of the many parts of the workflow where your existing policies for approvals, change, control, and business processes can be applied. Once the request passes through the important policies and rules, the service management tool or API can then call on Ansible to perform pre-installation checks. This allows for earlier issue detection where the so-called fail fast and fail early principle can be applied. If it passes the pre-installation checks, Ansible can then build workload-specific SOE via communicating with various tools or solutions such as SCCM for Windows and Red Hat Satellite for RHEL. Ansible can also work with VMware and cloud provider control planes for provisioning instances in the cloud. After an instance is provisioned, Ansible can then go ahead and apply whatever standard configuration your organization has and update any corporate standard configuration you may have as well, such as those relating to NTP and DNS, and making sure that the instance is compliant with various security standards, such as STIG, PCI DSS, or CIS, or perhaps you would like to install additional software like backup agents. This is also possible with Ansible. Once this is done, Ansible can then help with things pertaining to application builds and configs themselves, regardless if they are an application, database, middleware, or a COTS application. After that, other configuration tasks can be done, such as applying the right network configuration on virtual machines, applying whatever firewall or ACL policies are needed. After all that, Ansible can then do some basic sanity and compliance checks and even initiate penetration testing. For some organizations, they prefer using vulnerability testing tools such as Tenable Nessus to scan the instances prior to moving them to production. And finally, going through this entire process will help with a specific application or business outcome. Organizations can start out with self-service provisioning of instances that has the latest corporate standard for SOEs for both Windows and Linux deployed locally or in the cloud. And then organizations can build on top of that and enable consumers to include platform or application builds to the pipeline to quickly and efficiently deliver desired application or service. This is a typical workflow that can be fully automated using Ansible automation. As mentioned earlier, Ansible enables close collaboration spanning across multiple teams across the organization. Because as the process gets more and more complex, you need multiple teams across your organization to be able to work together to arrive at specific outcomes. And because Ansible content can be managed using a version control solution, various teams can contribute and further improve and optimize the process as they go along. The next thing I'd like to show you is a typical workflow for on-demand OS patching that can also be automated using Ansible, which can also be initiated by consumers themselves. And again, we start with the consumer filing a ticket or doing an API call to the service management tool. The service management tool then makes sure various related policies and processes take place, and after that, it proceeds to do an API call to Ansible to do pre-installation health checks to make sure everything is running fine. For those instances hosting critical applications and workloads, Ansible can automate the creation of snapshots and backups, and then schedule deletion of the said backups when the whole process succeeds. Once backup is done, Ansible can then integrate with existing patching tools such as SCCM or WSUS for Windows machines or Red Hat Satellite for their RHEL instances using Ansible patching modules. After that, Ansible can go ahead and install applications, databases, and so on. For some organizations, they also use Ansible to ensure applications are at the right patch or fix level required for compatibility, security, and stability. For platforms such as Windows, Ansible can also automate performing reboots when needed and also make sure that instances comes back online. Once the necessary reboots are done and the systems are back online, Ansible can then perform basic sanity and compliance checks to make sure that everything is working as expected and then do some penetration testing or vulnerability testing using solutions like Tenable Nessus. And because part of the workflow is taking a backup of the instances prior to doing any patching, when something goes wrong or some component fails to function the way it is expected to, organizations can also use Ansible to roll back the entire workflow and try the patching process again. As mentioned in the previous slides, people can be both consumers and contributors that will not only benefit from consuming Ansible automation, but they can also provide valuable feedback and contribute towards optimizing the workflow. With the previous examples, you can probably see that starting out towards a coordinated automation strategy doesn't have to start out perfect. You can slowly build your catalog as you also build your skills in Ansible. Let's now talk about some of the ways you can take it a step further with Ansible. Another thing organizations can do is integrate Ansible with monitoring tools such as Dynatrace or Zabbix to detect issues, and then Ansible can perform self-healing or automatic remediation of the affected applications or instances. Remediation could mean a simple service restart, or it could also be a process where the instance needs to be disconnected from the monitoring tool and the load balancers. Restart the instance entirely, and when everything is functioning right, connect it to the monitoring tool and the load balancer so it can resume normal operation. In the event that the issue still persists, Ansible can then help log a ticket for escalation and higher and deeper analysis. This can be done regardless of where the instance is deployed, whether on premise or in the cloud. The organization can then build a catalog of various automation workflows that can start with automating simple but time consuming repetitive tasks. And because Ansible enables multi tenancy, this means that multiple tenants benefit from a common approach for both on premise and cloud workloads, saving time, quickly realizing ROI, and gaining the ability to automate more complex use cases over the course of time. Some other examples of common use cases include provisioning and patching that is controlled from a central location, scheduled security hardening and compliance, self-service common simple requests, and so on. To help our customers get started with Ansible, we also offer various training and certification courses aimed at specific SMEs. We have courses for Linux admins, starting from foundational skills like Red Hat Enterprise Linux Administration, and building on top of that towards becoming a Red Hat certified engineer that specializes in advanced automation. We also have training and certification course for network admins, starting with the foundational RHEL skills. And lastly, if you're a Windows admin who'd like to learn how to automate your Windows environment using Ansible, we also have a course for you. And with that, I'd like to thank you all for attending, and I hope you now have a better understanding of how Ansible works and some of the most common use cases that your organizations can start with automation.
Thank you, Len, for that eye-opening session. Security and compliance are often cited as the biggest challenges when it comes to automation initiatives.
The same software that's assisting doctors with life-saving AI is powering global enterprises in the cloud and beyond. That's why our code is open.